In example 5, we're looking at which graphs increase the fastest. We have our f of x graph, and our f of x graph is our quadratic graph. It's our parabola. We have our g of x graph, which is our straight line. It's the red graph right here. And we have our h of x graph, which is the blue exponential function right here. In letter A, we want to answer which graph has the highest value when x is equal to negative 5. So if we go to an x value of negative 5, our red function is down here, in between negative 10 and negative 15. Our exponential function is super duper close to 0 right now. And our quadratic function looks like it's up here in between 30 and 35. So the highest function that we have right now is f of x. So for letter A, we can say f of x, which is our quadratic, has the highest value when x is equal to negative 5. And letter B, which graph has the highest value when x is equal to positive 5? So now we're coming here to positive 5. And if we look, our exponential function's right here on the bottom. It looks like it's just below 5. Then we get to our line, which looks like it's right below 10. And then we get to our quadratic function again, which right now is in between the 10 and the 15. So this quadratic is taller or bigger, higher than the linear and the exponential when x is 5. So for letter B, we can say that f of x has the highest value. In letter C, which graph has the highest value when x is equal to 15? So now we're taking a look when x is 15, which is here. We have our line that has fallen way below everything else. It's still kind of down here, right below 30. And then if we take a look, as we go up further, we're looking between our exponential and our quadratic function. And we want to kind of take in what we learned in the last example in terms of what's happening for big values of x with our exponential functions and our quadratic functions. If you look at your graph right here, about right here is where your quadratic and your exponential function are exactly the same. They're intersecting, they're the same height right here. And then after that height, that exponential function is getting bigger and bigger and bigger than that quadratic. So if x is equal to 15, that exponential function is going to be the highest graph as it is increasing the fastest from everything else. So for x equals 15, we would say that it is h of x. And then in letter D, is there a type of graph that will always increase faster than the others for large values of x? And our answer to that is yes. And that is our exponential functions. If you have questions, let me know.